Now let's integrate this function. The first thing that will come to your mind is that what kind of techniques of integration can we use? Well, what I would just suggest is that we need to rearrange first. And where to start from is to make this expression right here a perfect square. So how can we do that? Here is how it works. To make a trinomial a perfect square, all you need to do is to first make sure that the coefficient of x squared, the leading term, is 1. But fortunately enough, in this case, it's simply 1. Then after that, you can just take the coefficient of x, the middle term, which is 1, then multiply it by half and square the result. Okay, so that's simply 1 over 4. Perfect. Now what I'm going to do right now is that I'm going to add it to this side, and I'm going to subtract it from this side, so as to make sure that everything is set balanced, as if I've not done anything different. So that's what I'm going to do right now. So it means the function will now turns out to be x minus 1 all divided by x squared plus x, then plus 1 over 4 plus 1, then minus 1 over 4. The x, don't forget, we are integrating that. Now, simplifying forward, I'm now going to have x minus 1 all divided by the expression I'm now having over it is now a perfect square. So I can write it as a square of an expression within a bracket. So how is that possible? First, I'm just going to take the square root of the first term, which is x. However, I'm going to enclose that within parentheses. And I'm going to take the square root of the last term, which is 1 over 4. So it's going to be 1 over 2. The square root of 1 over 4 is simply 1 over 2. Then outside the parentheses, I'm going to put square. Okay. Now, what should be the sign that will be connecting x and half? That will depend on the sign that is associated with the middle term. So in this case, simply addition. So I'm just going to put addition over there. Okay. Perfect. So now let me simplify this. Positive 1, negative 1 over 4. So if the LCM is 4, so I'm going to have 4 times 1, that's 4 minus 1. So that should be 3 over 4. Perfect. So at this point, what are we to do next? What I will suggest right now is that we can now use the u substitution by setting u to be equals to x plus half. So with this, we can clearly try to make some substitution. Now, if u is equals to x plus half, the u over the x will simply be equals to 1. And eventually, the u will simply be equals to the x. Perfect. Now, I would like to have u, x rather, in terms of u, using this equation over here. And to do that, what I'm going to do is just to bring this half to the side. And with that, I should have x to be equals to u minus half. I think this is all I need for now to substitute in the given problem. So right now, I don't need the question anymore, so I cannot get rid of it. So at this point, the integral returns out to be of this form. So I'm going to replace x over here with u minus half. So it will now become u minus half. Then negative 1 is over here, minus 1. Everything divided by x plus half, we have replaced that with u. So it will now become u squared plus 3 over 4. Now we said the u is indeed equals to the x. So we don't need to bother about that. We just need to replace with the u. Now let's try to simplify it to some simpler form. So this will be u. What is the value of minus half minus 1? If the LCM is 2, 2 in 2, that's simply 1. And 1 times negative 1 is negative 1. 2 in 1, that's simply 1 in 2, rather, that's simply 2. 2 times negative 1, that's negative 2. So that should be indeed equals to negative 3 over 2. Perfect. So this will be negative 3 over 2. And we are dividing all through by u squared plus 3 over 4. Interesting. Right now, what I would suggest is that we can try to get rid of the fractions. Let's try to balance everything. Let's linearize this function so as to make our integration process simple and straightforward. So to do this, what I'm going to just do is just to multiply both the numerator and the denominator by 4. because I can see that this will help us to get rid of this fractions and this fraction. Perfect. So that's going to become 4 multiplied by u minus 3 over 2, then all divided by 4 multiplied by u squared plus 3 over 4. Then I have the u outside the bracket. Okay, perfect. So that now is going to become the integral of 4u, the minus this 4 multiplied by 3 over 2, that should be a result in 6, divided by 4 multiplied by u squared, that's 4u squared, then 4 multiplied by 3 over 4, that says indeed equals to 3, and I have the u. So it turns out that there's a common factor between the terms I'm having at the numerator, which is indeed equals to 2. So I'm just going to factor that out. So that's going to be 2 multiplied by 2u minus 3. I hope you got that, because if I use this 2 to expand the bracket back, then I'm still going to have what I'm having in the first place, which is this. Good. So I'm dividing this by 4u squared plus 3 du. Interesting. So right now, I would like to bring the 2 outside the integration symbol. So just to make things easy, that's what we're trying to do right away, okay? So 2 outside the integration symbol, left over we have 2u minus 3, all divided by 4u squared plus 3, then du. Now, what are we to do at this point? At this point, we can just simplify. Let's split the numerator, okay? Let's split the numerator, because this will help us to be able to integrate this function, because as it is right now, we can't still integrate it, as there's no any techniques we can apply for now. So let's try to break the numerator. So this will simply be equals to 2 multiplied. I'm going to put that outside a closed bracket, then I have the integration of 2u all divided by 4u squared plus 3. So I'm trying to use the sum method of integration. You understand? We can dispute the integration symbol. So I'm adding that to the integral of negative 3 all divided by 4u squared plus 3. This is interesting. Perfect. So this pretty much easy to integrate right now. So before I do that, I would like to bring the negative 1, or let me just bring the whole negative 3 outside the integration symbol right there. So right now, it's going to become this way. It's not going to be 2 multiplied by the integral of 2u all divided by 4u squared plus 3, then minus 3 integral of 1 over 4u squared plus 3. Perfect. Now I would like to integrate these functions one after the other. So for now, I'll focus on this side. So how can I integrate 2u all divided by 4u squared plus 3? Now what I will do is to make use of the u substitution. But in this case, u is already in the function. Don't forget, we are integrating everything with respect to u. Okay? Kindly bear that with me. It's sometimes skip my mind. I wasn't associating the u with it. Okay, that's fine. Now, instead of substituting u, I will substitute y. So let y be equals to 4u squared plus 3. Then the y over the u will simply be equals to 8u. I believe you got that. Now, what I will do next is just to substitute. I want to solve for the u, okay, in terms of the y and u. Very good. So that's going to be, if I cross multiply, it turns out that the u will simply be equals to the y over 8u. Very good. Now I can proceed on substituting. So it's going to become the integral of 2u all divided by, so don't forget I've replaced this with y. So that's going to be y, then multiply by, now the u we said is indeed equals to the y over 8u. So that's going to be the y over 8u. So right now we can clearly see that the u's are going to cancel out. And 2 here 1, 2 here 4, that will reduce to 4. And finally, this integral will become the integration of 1 over 4y. And I can clearly simplify this to 1 over 4 integral of 1 over y. By the time I bring the 1 over 4 outside the integration symbol. Don't forget we are integrating this with respect to y. With respect to y. Perfect. So what exactly is the integral of 1 over y with respect to y? What do you think? This will simply be equals to ln y. Okay. However, we need to put the absolute values simply equals to ln y. So you have to make sure that you associate the absolute value with it. So that is the integration for this first part of the problem. So don't forget, the problem is given to us, the expression in terms of x. But for now, we are having some of things in terms of y, so we need to replace. Let's substitute back. So how can we do that? Let me try to create some more space. For now, we don't need any of this, so I can clearly get rid of them. So we can clearly see that the integration has become 2, then multiplied by 1 over 4, ln absolute value of y, then minus 3, integral of 1 over 4u squared plus 3 du. Perfect. So for now, let me just try to replace y back, okay? Earlier, well, unfortunately, I've actually get rid of that, but I can recall that vividly. Let me just put it at the left-hand side, over at the right-hand side over here. We said it earlier that y is equals to 4u squared plus 3. So that's what I'm going to do right now. I'm just going to replace y with 4u squared plus 3. Like, I want to make sure that I have everything over here being solved before I proceed to this other side, okay? That's going to be 2. Then I have 1 over 4. And then absolute value of 4u squared plus 3. The minus 3. The integral of 1 over 4u squared plus 3. The u. So over here as well, we said that u is equals to x plus half. So I would like to replace u with x plus half over here. So that would be 2, then multiplied by 1 over 4, ln absolute value of 4 multiplied by x plus half all squared, then plus 3. Yeah, I'll close the absolute value. The minus 3, the integral of 1 over 4u squared plus 3, the u. Perfect. Now let's try to just simplify to some simpler form. So definitely this will eventually be 2, then multiplied by 1 over 4, ln. So what is the value of x plus half squared? What would that be? Well, let me just quickly try to expand it over here. X plus half squared simply means x plus half to be multiplying itself 2 times, okay? That's x plus half. So to expand this, like we are just going to dispute each term respectively. So that will be x squared, x times half, that's positive x over 2. Then half times x, that's positive x over 2 as well. Then half times half, that's positive 1 over 4. So since these are like terms, you can add them up. So they should eventually be x squared plus, so that will be x, then plus 1 over 4. Yes, that's how it's going to be. So this is the final answer. Well, it's just that x plus half squared is the same thing as what we got earlier over there. But I don't just want to refer you back to what we have discussed so far. That's why I just need to expand it for you people to see how it works. So therefore, we are replacing x plus half all squared with x squared plus x plus 1 over 4. Perfect. So that's going to be this. So 4 times, okay, let me use the white color. X squared plus x plus 1 over 4, then plus 3, and close the absolute value, minus 3, the integral of 1 over 4 u squared plus 3, the u. Interesting. Right now, we are proceeding, we're almost there. Almost there. So that will be 2 then multiplied by 1 over 4 ln. So I would like to distribute the 4 right now, we distribute the 4 respectively. So that will be 4 times x squared, that's 4x squared. Then 4 times x. 4 times x, that's 4x plus 4x. Then 4 times 1 over 4, that should be 1. That's just 1. That's just 1. That's just 1. And I'm adding plus 3 to that. Okay? Don't forget it is going to be within the absolute value minus 3, the integral of 1 over 4u squared plus 3, the u, and close the bracket. So finally, for this hand side, we can have it of this form. 1 over 4 ln absolute value of 4x squared plus 4x plus 4. Perfect. So I'm through with this side. That's all for now. That's just the integration of that aspect. So I have 4u squared plus 3, the u. Now, let's focus on this. The integral of 1 over 4u squared plus 3, the u. So what integration techniques should we use to solve this kind of function? What do you think? What suggestion do you have to that? Well, the best thing we can do is to use the trigonometry substitution, and we'll be using that of tangent function and precise, because the function we're having right now, it's similar to that of the tangent function. Okay, so therefore, to be able to use a tangent function, the value of x is simply equals to a tan theta. Okay, and x in this case is equals to the square root of the first term over here. Okay, that will be the square root of 4u squared. And at the same time, we can get x to be equals to 2u. Now, the value of a will be this. However, it has to be in a perfect square. So we need to rearrange this. For it to be a perfect square, I think we just need to express it of this form. It should be of this form. 1 over 4u squared plus the square root of 3 all squared. This makes sense. It doesn't change anything. This will eventually be this back. Okay, we just did this to get the value of a. So a in this case will be equals to square root of 3. Fine, we have everything we need. Let's proceed. So therefore x will now be equals to square root of 3 tan theta. Okay, and the x is equals to 2u. So I'm replacing 2u to be equals to square root of 3 tan theta. And eventually, if I divide through by 2 over here, okay, let me create some more space. However, I still need this, not bad. So you can just get rid of this. So if I divide both sides by 2, we can clearly have u to be equals to square root of 3 over 2 tan theta. Perfect. Now we need the value of the u, so we need to differentiate the function with respect to theta. So what exactly is the u over the theta? Okay, the space won't be enough. Let me just try to get rid of all these ones. I don't think we need them anymore. Anyway, okay, well, we can need some parts. Let me just write it at the right hand side over here. So x is equals to a tan theta. We might need that later on. And at the same time, u is equals to square root of 3 over 2 tan theta. Okay, for now, I think that's all we need. So we can get rid of any other aspect. Now, we want to find the u over the theta. So the derivative of tan theta is simply sec squared theta. So that will be square root of 3 over 2 sec squared theta. And I would like to solve for the u. So if I cross multiply, I will have 2 the u to be equals to square root of 3 sec squared theta multiplied by the theta. And if I divide through by 2, eventually the u will simply be equals to square root of 3 sec squared theta over 2 the theta. Interesting. So right now we can substitute. So the integral will become the integral of 1 divided by 4 multiplied by the value of u is with 3 over 2. Don't forget this is 2. With 3 over 2 tan theta, that's square root of 3 over 2 tan theta. Don't forget we are squaring this, so squared. Then divided by 3. Then we are multiplying that with the u, and the u is square root of 3 over 2 as well. Sec squared theta. Then we have the theta. Very good. Now I can get rid of this as we are no more in use of it as well. Okay. And so it's going to become the integration of square root of 3 over 2 sec squared theta over 4 multiplied by with 3 over 2 tan theta all squared. Then plus 3, positive signs there, plus 3 the theta. Good. Now I'll bring this with 3 over 2 outside the integration symbol. That will be with 3 over 2. Then the integral of secant squared theta all divided by 4. So let me expand this. To expand this, I will just distribute the square to everything within the parentheses. So that'll be 4 multiplied by, that should be 3 over 4. You know, the root will cancel the root. Okay, this is what I'm saying. With 3 over 2 squared simply stand for with 3 over 2 times with 3 over 2. With 3 times with 3, that's simply 3. And 2 times 2, that's simply 4. So that I got this 3 over 4 right here. Okay, hopefully that aspect is clear. Okay, having done that, then the square of tan theta, that's tan squared theta. Then I'm adding plus 3, the theta. So that will be with 3 over 2, the integral of secant squared theta. So let me expand. Let me distribute the 4 now. Turns out that the 4 will cancel each other. Okay, so that will now be 3 tan squared theta plus 3. Okay, very good. The theta. So at the denominator, there's something we need to observe there. We can clearly see that 3 is common in all cases. Okay, 3 is common. So that's what we are going to focus on. We can just like factor out the 3, and which will become square root of 3 over 2. Then the integral of secant squared theta all divided by 3 multiplied by tan squared theta plus 1. Then the theta. So right now, let me bring the 3 outside. So that will be with 3 over 2 multiplied by 1 over 3. The integral of secant squared theta all divided by tan squared theta plus 1. The theta. Nice. Now we need to go back to trigonometric identities. Some of the identities of trigonometry is that the square of tangent function plus 1 is simply the square of the secant function. Okay, we can't prove that for this video because I don't want the video to be too long, but just check out a review of trigonometric identities and you should be able to see where the theorem is. Okay, so I'm going to replace tan squared theta plus 1 with secant squared theta, and that will be over 3 over 6, because I've multiplied these 2 and 3 together. So with 3 over 6 multiplied by the integral of secant squared theta all divided by secant squared theta, the theta. This cancels out, that results in 1. Then we can clearly have, oh, oops, my bad. We can clearly have square root of 3 over 2, okay, over 6, the integral of 1, the theta. So the integral of 1, that's simply with respect to theta, that will be theta. That will be 3 over 6 times theta. Now, don't forget, our answer has to be in terms of x, so we need to be reversing back now. Okay, so what is the value of theta? We can use this equation right here. We said u is equals to square root of 3 over 2 tan theta. If we cross multiply, you can see that 2u equals square root of 3 tan theta. If I divide 2 by root 3, you can see that 2u over root 3 will be equals to tan theta. Then right now, I will just take the arctan of both sides. That is, I will take the tan inverse of both sides. Then we can clearly have the value of theta to be equals to the tan inverse of 2u over root 3. Perfect. So that's the tan inverse of that's the value of theta. So I'm just going to replace theta with that, and which will become this. So it's now be root 3 over 6 multiplied by the tan inverse of 2u over root 3. Now we said u is equals to x plus half. Okay, we need to replace u as well. So this will simply be equals to square root of 3 over 6, then multiplied by tan inverse of 2 multiplied by, I'm replacing u with x plus half now. So that will be x plus half. Okay, over then with 3. Very nice. So it means eventually this is what we are going to have the integral of that other side, which is this side, to be. So this is the side I'm referring to, okay? So that will now be square root of 3 over 6 tan inverse of 2x plus 1, because this 2 will affect this to be 2x, and to make this to be 1, okay? That's it. And all divided by square root of 3. And that's it. I think that's the least and the lowest simplification we can do to that function. So let's just combine everything together. I'm just going to remove this, and I'm going to plug in this, and that will be the end of this problem. So let's see how it works. So therefore, it's not going to be 2 multiplied by 1 over 4 ln absolute value of 4x squared plus 4x plus 4, then minus 3, then we are multiplying that with square root of 3 over 6, right? Then tan inverse of 2x plus 1 all divided by 3. Very good. So I can get it up this clearly. And that will now be, this will reduce this. And I would like to distribute the 2. Let me distribute the 2 to this and to this, just to have a final answer once and for all. So this 2 will reduce this to be 1 over 2 ln absolute value of 4x squared plus 4x plus 4, then minus, so this will be left with 2. So the 2 will reduce that, that will be minus with 3 tan inverse of 2x plus 1 all divided by square root of 3. And this will be our final answer to this problem. Hopefully you find this content helpful. If you haven't subscribed to my channel, please do subscribe to my channel. Thanks for watching. Feel free to share the video to your loved ones and to anyone you think would be of benefits to. Thanks for watching. See you guys in the next video. Bye for now.